this is section 6-4. It's called nth roots. We have worked, and you should have a handout for this that I gave you, so you would be taking notes on this paper. So we have worked with square root functions. Now we are going to work with other roots like cube root functions, fourth root functions, and we're going to learn how to simplify radicals. Some of this is going to be review because I've shown you how to do this already, and then using your calculator to approximate radicals, which of course will not be hard to do. So some new vocabulary would be nth root. The radical sign looks like this. When you have an index value, the index value is whatever goes in this spot right here. So for example, maybe you were going to take the fourth root of something. So then that index value would be a 4. The radicand is what's underneath here. So maybe you're taking the fourth root of 81. And the principal root we will talk about when we get to a problem like that. So for simplifying radicals, I'm just going to kind of read through this. Finding the square root of a number and squaring a number are inverse operations. To find the square root of a number a, you must find a number with a square of a. Similarly, the inverse of raising a number to the nth power is finding the nth root of a number. So when you look through these, you know, suppose you were told that x cubed equals 64. Well, you know that 4 times, or you could see that 4 times 4 times 4 is 64. So there's 3 factors of 4 that make that up. 4 is a cube root of 64. So we could say the cube root of 64 is 4. So notice how we have x cubed equals 64 written as a power, or the cube root of 64 equals 4 written as a root. This is the inverse of cubing. So if you have x to the 4th power equals 625, notice over here, 5 to the 4th power is 625, which means the 4th root of 625 is 5. Here we have x to the 5th equals 32. So think of this as 2 to the 5th power. So then the 5th root of 32 is 2. And then in general, if you have a to the n equals b, then you could say the nth root of b equals a. So it's just the inverse is all that means. So some of this I already showed you. So some of the values, and the terminology. So this symbol would represent the nth root with a little n there in that place. Normally we'd have a number. So that's the index value. The radical sign is the part that looks kind of like a little bit like a divide sign, but it's not radical. It's the radical sign. The radicand is what's underneath. Now, sometimes some numbers have more than one real nth root. For example, 64 has 2 square roots because 8 squared is 64, and -8, that quantity squared, is also 64. So when there's more than one real root and n is even, the non-negative root is called the principal root. So typically, if I were to put into my calculator the square root of 25, notice I just get 5 because I'm already evaluating the square root. And we've talked about this in class. If I had something like x squared equals 25 and I square root both sides, remember x could be 5, since 5 squared is 25, or x could be -5, since -5 squared equals 25. That was the reason why when you square root both sides, remember we always had plus or minus the square root of 25, which was plus or minus 5. Well, the principal square root is just not the negative part of it, just the positive part of it. So the principal square root, when you take the square root of that, you get 5. Now, if you have a negative sign in front of the radical sign, the negative and then the square root of 25, you evaluate the square root of 25 as 5, but then you're taking the opposite of that, so you get -5. If you take the square root of 25 and you have a plus or minus, we've done this before, then you get plus or minus 5 because you're using both square roots. So it just kind of depends on what you're asked for. If you're already given the problem in radical form, then whether or not you have if it's positive or negative, you only have one answer though, if you're already given it in radical form. Okay. I'm actually going to come back to this after we go over some problems, and we'll see this part later. So here's our first example. We want to simplify. It's plus or minus. So because there's a plus or minus here, I know already that my answer is going to be plus or minus. This is a square root. Remember, if you do not have a root sign here or the index value is missing, that means it's square root. That's what we use normally, so that's kind of the default. We already have a way to think about this because we've talked about this before. If we want to think of this as the square root of 16, and you want the largest perfect, well, that is a perfect square. So I'm not even going to do that. We know the square root of 16 is 4 because that's a perfect square. So we've dealt with that before. I want to consider this x to the 8th power. And I want you to think of it as x to the 4th squared. Because remember, power to a power, you multiply the exponents. So if you square root that, notice that I can think of this as x to the 4th times x to the 4th. So when I square root it, I actually get x to the 4th. And so here's a shortcut that you can do with the index value. For the numbers, stick with what we know. We've done that before. So the square root of 16 is 4. For the variables, we're going to do a little trick with the exponents. 2 goes into 8 4 times with nothing left over. So that means that's going to tell me what my exponent is, x to the 4th power. So let me kind of redo what I was saying here. So let's think of this, this x to the 8th as x squared times x squared times x squared times x squared, because I'm taking the square root. So if I'm taking the square root of that, the square root of x squared is x, the square root of x squared is x, the square root of this x squared is x, the square root of this x squared is x, so I get x to the 4th power. So that's kind of what's happening, but that's a great shortcut. 2 goes into 8 4 times, so that's going to be my power. There's nothing left over. So we get this. Stick with what you know with the numbers. For this next one, this is a 2 right here. Now notice the parentheses. That means you're not going to change this at all. And you're just going to say 2 goes into 4 2 times with nothing left over. So my answer is just this, because 2 goes into 4 2 times with nothing left over. That's the easy way that you can do that. It's negative because it was negative here. All right, next example. Remember what I said for the numbers? We're going to just do what we have done before. So you might even want to come over here, and we're going to break down this 243. So I need to find a number that goes into that evenly. I'm pretty sure, well, I know it's not 2 because it's not even. So I'm going to try 243 divided by 3. And notice I get 81. Okay, so I'm going to break this down. I get 81 times 3. Well, I know this is 9 times 9. I know this 9 is 3 times 3. And this is 3 times 3. So notice I have a 3 times 3 times 3 times 3 times 3. This is prime factorization. So I'm going to rewrite the 243 as 3 to the 5th power. Well, if I'm taking the 5th root of 3 to the 5th power, those are inverses. They cancel out and I just get 3. So for the number part, I get 3. Now, on your calculator, because this one works out evenly, if you want to evaluate the 5th root of 243, you do that with this math key, and you want number 5. We need to come over here and put in this number apparently. So I'll put in let me clear that. Let's put the 5 in there, and 243, and we get 3. Okay, so you can evaluate that on your calculator. So I get 3. And then now for the variable parts, I'm going to use our little trick. 5 goes into 10 2 times, nothing left over. 5 goes into 15 3 times, nothing left over. So that's my answer. Now on a problem like this, part D, you'll be much better at because this is square root. Now you know the square root of 4 is 2, And hopefully you all remember what to do with this negative when it's under the radical, because the square root, remember the square root of -1 equals I. So my answer is just 2I. So that's not new. This with a fifth root is new. Okay, so you have 1, 2, 3. You have 3 problems to try. So pause the video and give those a try. Okay, so hopefully you paused it and tried them. First of all, we know our answer has to have plus or minus in it. So right away, it can't be C. We know it's a square root. Since there's nothing there, we know it's square root. So the square root of 9, so we're going to get plus or minus. I'm going to put the 2 there. It's going to help you with the variable part. The square root of 9 is 3. And 2 goes into 8 4 times with nothing left over. So you should have gotten B as your answer. Now here's what sometimes people do. Don't do this. This idea that 2 goes into 8 4 times with nothing left over, then they want to say, well, 2 goes into 9 4.5 times and put, no, don't do that. You're doing the square root of 9. Just to show you that it really would work if we changed it to this. 9 is 3 squared. 2 goes into 2 1 time with nothing left over, so we have a 3. 2 goes into 8 4 times with nothing left over, so we have x to the 4th. So if you changed it to an exponential form, then the little exponent thing would work for the numbers too. Okay, for this one, first of all, we have a negative sign out front, so we know we have to have a negative sign out front in our answer, so it can't be those. Remember that this is square root. 2, and this is parentheses, so you're not going to separate that out. So 2 goes into 8 4 times with nothing left over. So then we get this for our answer. So that's what you should have gotten. And on this one, there is no plus or minus, so that can't be the answer. Be careful on here. Don't say 5 goes into 32, because we're doing the fifth root of 32. But you can break down this 32. I'm just going to do a little prime factorization here. So we have 8 times 4 is 32, 4 times 2, 2 times 2. So I'm just prime factoring. So notice I have 5 2's, so this is 2 to the 5th power. So let's rewrite it that way. So we get the 5th root, 2 to the 5th power, x to the 5th power, y to the 10th power. So 5 goes into 5 1 time with nothing left over, so there's a 2. We're going to have an x, and we're going to have a y squared. 2xy squared, so our answer is A. So hopefully you did okay with those. All right, this next problem. Simplify the 6th root of t to the 6th power. Now, when you look at that, I know you're going to say, oh, this is easy. 6 goes into 6 1 time with nothing left over. So my answer is just t to the 1st or just t, either one. So let's try it out. Let's see what happens if t equals 3, and let's see if that works. So if I were to take the 6th root of 3 to the 6th power, and I'm going to do that on my calculator. So if we do the 6th root, okay, this is a problem. Here we go. The 6th root of 3, oops, let's put parentheses there, 3 to the 6th power, and I get 3. Well, that seems reasonable because I'm supposed to get t, taking that, I'm supposed to get back whatever I put in, I'm supposed to get out, right? So now let's try this. The 6th root of -2 to the 6th power. So if we try that, whoops, didn't want that key. So we got to put parentheses here. I get 2. I didn't get -2. I put a -2 in, but I got a +2 out. That's always going to happen because look what we're doing. We're raising it to an even power, and then I'm going to lose my negative sign. So I'm not going to get what I put into it. I'm not going to get out. I'm going to get the opposite. Or I'm going to get the absolute value because I'm always going to get a positive result out when I take that even root. So here's what you have to do for your answer. we have to say, when we simplify this, the 6th root of t to the 6th power, we don't get t, we get the absolute value of t, which is why this says simplify using absolute values. So when does that happen? Well, it's only going to happen under these situations. When you have an even power in your radicand and you have an even root for your answer, but you have an odd power. I'm sorry, I said the index value, even root, but you have an odd power for your answer. That's when you have that potential that is going to be where you need to include the absolute value. Okay, so looking at this, on this problem, notice I have an odd here and I have an odd root. So I don't need absolute value on this one, because if it's an odd root, you will never need absolute value. It's only going to happen when it's an even. So for this problem, I'm going to have to break down the 243. And I think we already did. I think we already determined 3 to the 5th power was 243, but we can check that easy enough. Yep, so that means the 5th root, that means the 5th root of 243 must be 3. So we're going to get a 3. And then now I'm going to leave the x plus 2 together. 5 goes into 15 3 times with nothing left over. So that's my answer. But this does not qualify for having to need the absolute value on it. All right, so I think there is 2 problems for you to try. So go ahead and do those. So pause the video and then do those problems and then restart it. Okay, so on this one, again, when you first look at it, you might think, oh, the answer is just going to be x. But we have an even power, an even root, and an odd power in our answer. So you need absolute value. And you don't need the 1 since it's the 1st power. So you are going to have this. Then for this one, the cube root of 27. Remember that 3 cubed is 27, which means the cube root of 27 is 3. So we get a 3. Keep this part together. And then you can use the little trick. 3 goes into 9 3 times with nothing left over. Now, this was odd and odd, so we already know, even without looking on, we do not need absolute value. So our answer would be B. All right, word problem. Designers must create satellites that can resist damage from being struck by small particles of dust and rocks. A study showed that the diameter in millimeters, d, of the hole created in a solar cell by a dust particle traveling with energy k in joules is about d equals 0.926 cube root of k minus 0.169. Estimate the diameter of a hole created by a particle traveling with energy 3.5 joules. So we're given this information. We're told that K is what is in joules, the energy. So all you're going to do is substitute that in. So we get D equals 0.926 times the cube root of 3.5 minus 0.169. And you can go to your calculator and punch it in just like it's written. So we're going to do, now there's actually a cube root on here, number 4. So we have the cube root of 3.5. Hit the arrow key to get out of the radical, minus 0.169. And we get that D, estimate the diameter. They don't tell us what to round to, so I'm going to go to the hundredths place, 1.24. And what units did it say my diameter was in? Millimeters. Make sure, if it's a word problem, make sure you are always checking to see if we have units that we need. All right, part B says, this kind of gives the same thing. It's just the question at the end, so I don't need to read it again. If a hole has diameter of 2.5 millimeters, estimate the energy with which the particle that made the hole was traveling. So this is the diameter, that goes in for D. So we get 2.5 equals 0.926 times the cube root of K minus 0.169. So now we're going to have to Let's see if I can move this up here. Well, now we're going to have to solve for k. So I'm going to start by adding the 0.169 to both sides. So 2.5 plus 0.169. So I'm going to get 2.669. Okay, now I'm trying to get this by itself, the k, but first I'm going to undo multiplying by 0.926, so I'm going to divide both sides by 0.926, and I get 2.882. Now notice that I'm leaving my answer in here. I'm going to leave that in my calculator for the next part, even though I'm rounding on paper. And then now I want to undo cube rooting. Well, to undo cube rooting, I cube both sides. So I'm going to leave this, what's in my calculator, and just cube it. So I get k is approximately 23.94 joules. Okay, not too hard. All right, looks like you have a couple problems to try, so go ahead and pause it and give those a try. All right, so we have our formula here, and they tell us that L is the length of the pendulum, G is the acceleration due to gravity, that's a constant, and we want to find the value of T for a 2-foot long pendulum. So this right here, they're telling us this is L. So we're going to have, we're trying to find the value of T. So T equals 2 pi times the square root of 2 over 32. And you can come over to your calculator. We're going to use 2. Now make sure you always go use the pi key. Don't use 3.14 as an approximation or anything. And then the square root of 2, you can do it as a fraction. I'm just going to do 2 divided by 32. So I get about 1.57 seconds. So there's our answer for that one. And for the next problem, same setup. How long is the pendulum if it takes 5 seconds to swing back and forth? So now we're told this is 5. And we're trying to solve for how long the pendulum is, but the gravity is acceleration due to gravity, we still have is 32. So I'm solving this. So I need to I'm going to isolate my square root, so I'm going to divide by 2 pi. Now, when you do that, so I'm going to set it up as a fraction. I'm going to show you a couple different things because I want to show you some common mistakes. 5 over 2 pi. So I can do that, and I get that answer. A lot of times people do this, 5 divided by 2 pi. And notice you get something very different. And here's why. Your calculator is doing 5 divided by 2, which is 5 halves, or 2.5, and then it's multiplying by pi because it's doing order of operations. So if you wanted it to do 5 divided by 2 pi and you decided you were just going to use not use the fraction key, you can, but you have to put parentheses around the 2 pi because you want it to multiply the 2 pi, you want it to divide by that, the whole thing. And then notice you get that same thing. So that's what I get over on that side. So we have 0.796 equals the square root of L over 32. Now I want to square both sides so that I can undo this part. So I'm just going to square this. So if I just hit the square key, it will take my previous answer. So I get I forgot to put my square here. 0.633 is, and I know it's approximately L over 32. And now I'm going to multiply that answer by 32. Notice I'm leaving the non-rounded answer in my calculator that I'm working with. So I get about 20.3, and that would be in feet. So that is my answer. So I just want to talk about one more example about when to use absolute value. So notice here I have an even power I have an even root. So this is where I could have that potential. And so when I'm evaluating this, my shortcut with the variables, 4 goes into 12 3 times with nothing left over, so I get a cubed. Now, even, odd, need absolute value. Okay, so whenever you have an even root, an even power, and an odd power in your answer, that's where you need the absolute value. So just wanted to make sure you guys are clear on that. Now, you might wonder, why do I always say with nothing left over? Because what if this had been the 4th root of a to the 13th power? 4 goes into 13 3 times, but there's 1 left over. So the one that's left over stays underneath the radical sign. Okay, so 4 goes into 13 3 times with 1 left over. So here's my 3 times with 1 left over. So that's what you would do if you have something left over. Now, this part out here still, so the even, odd thing. Let me think. Okay, not an issue. Wouldn't need absolute value because this is an odd power. The value of a cannot be negative because if it was, raising to an odd power would keep it negative, and I can't take an even root of a negative number if I have real numbers. So I don't have to worry because, so it does have to be even, and this is not, so I would be okay with that. However, if it was this, if I had a to the 14th, 4 goes into 14 3 times with 2 left over, I still have the potential where a could have been negative because even, and what came out was odd. So I would need absolute value in that case. I don't know that you guys have anything where there's something left over today, but I just wanted to talk about that. So you'd be ready for it if you see it.